In this video, I am going to discuss about the inverse Laplace transform. Do you remember our goal on this chapter is use the Laplace transform and its inverse Laplace transform to solve a differential equation with constant coefficient, ODE with constant coefficient. Okay, so let us define it. Is just the reverse process or the inverse process. So if ft is a piecewise continuous and of exponential order on the interval 0 to infinity, and if the Laplace transform of ft is uppercase fs, then we call ft is the inverse Laplace transform of fs. We write inverse Laplace transform of fs is equals to ft. Okay, so if there is a constant multiplied here inside, and if you're taking the inverse Laplace transform, you can take that outside and then find the multiply from outside. You can do that. Okay, if any constant can be pulled outside from the inverse Laplace transform. Basically it is linear. Okay, so if there is like sum of the inverse Laplace transform or difference of the inverse Laplace transform, you can just separate those sum and difference. Okay, so we'll discuss that later. For now, let us focus on just the inverse Laplace transform of the function. If the Laplace transform of the lowercase ft is uppercase fs, then inverse Laplace transform of uppercase fs is lowercase ft. Let us do this example. Find the inverse Laplace transform of this. Okay, so what you want to find is you want to find out inverse Laplace transform of 30 over s squared plus 25. That's what you want to find out. Okay, do you remember what is the Laplace transform of sine at? What do you think? This is a over a square plus s square, right? Or s square plus a square, right? So look at this. Isn't this similar to that? In the top there is a number, and in the bottom there is some square s square. There is s square plus a square. But you can work with this. So what you can do is you can write this as 6 times 5, right? So what we can do here is you can pull that 6 outside and then do Laplace transform of 5 over s square plus 25, right? You see that inverse Laplace transform of that. So see, what is the inverse Laplace transform of this? This will be sine at, right? Since the Laplace transform of sine at is a over a square plus s square, so the inverse Laplace transform of a over a square plus s square will be sine at. So it will be 6 is there. So the inverse Laplace transform of this will be sine 5t. That is the answer. So this is how we find out the inverse Laplace transform. Okay, let us look at this. So what do you think? So we need to find a function whose Laplace transform will be this, right? So we need to find out a function whose Laplace transform is this, which is same as finding the inverse Laplace transform. Okay, so what do we know? So we know that Laplace transform of t cubed is how much? It is 1 over s to the, so 3 factorial over s to the 4th, right? So 3 factorial, that is 6 over s to the 4th. You see that? That is the Laplace transform of t cubed, right? So, but there is 6 over, but there is s plus 2. What may be coming there? So also, do you remember this? Laplace transform of e to the at, right? And then ft will be how much? Do you remember that? That will be f of s minus a, right? If there is plus a, there will be s minus a, right? So if you do this, then what will be the Laplace transform of, let's say, e to the at, let's take ft is t cubed. This will become f of, this is basically fs, right? That is the fs. Now this will become, you see that f of s minus a, right? So what is f? It is 6 over s to the 4th, but s should be replaced by s minus a. So you will get s 6 over s minus a to the 4th, right? But we did plus 2. So what should be the value of a? A must be negative 2, right? A must be negative 2. So what we can do here is basically, since Laplace transform of e to the minus twice t times t cubed equals to, it will be the, so what we do for this is basically we find out the Laplace transform of this is 3 factorial over s to the 4th, right? So 3 factorial over s to the 4th, and then s should be replaced by s plus a, sorry, s minus a. That will give you 3 factorial over s plus 2 to the 4th, right? That is 6 over s plus 2 to the 4th. So the inverse Laplace transform of 6 over s plus 2 to the 4th equals to e to the negative twice t times t cubed. That's the answer. That's how you find out the inverse Laplace transform. So to find out, it is like a derivative and antiderivative, right? So just use find out the function whose Laplace transform is that function, is basically finding the inverse Laplace transform, right? How do I do this problem? See, there is s plus 1 in the top. So can we get s plus 1 on the bottom? Let us simplify the bottom and then get the complete the square. So I will get s plus 1 over s plus 1 square is s square plus 2s plus 1 plus 4. You see that? Yes. So this is basically s plus 1 over s plus 1 square plus 4. Because what is s plus 1 square? S plus 1 square is s plus 1 times s plus 1, right? So if you simplify that, that will be s square plus 2s plus 1. So 5 can be written as 1 plus 4. So it will be 1 plus 4, and then s square plus 2s plus 1 will be s plus 1 square, and plus 4 is plus 4. Now you see that this is like s square plus a square form, but there is no number on the top. There is a variable on the top. That variable matches perfectly with this, right? So what we do is, since Laplace transform of cosine of at. What is the Laplace transform of cosine of at? It is s over s square plus a square, right? Look at that. So we need to replace s by s plus 1, right? So to do that, what do I need to multiply here? It will be e to the negative t, right? If e to the negative 1 times t, that will do exactly the same formula there, right? So there, and Laplace transform, and the Laplace transform of e to the bt cosine at. What is the Laplace transform of this? So the cosine at has s over x square plus a square, but since there is b, we need to replace s by s minus b, right? So it will be s minus b over s minus b square plus a square, right? Now look at that. Aren't they similar? What should be the value of a? The value of a must be 2, right? Because this is 2 square. A must be 2, and then b must be negative 1, right? Hence what you get is inverse Laplace transform of s plus 1 over s plus 1 square plus 4 is equals to, basically we take b equals negative 1 to get s plus 1, right? And then a equals to 2. So the inverse Laplace transform of this is that thing, right? So it will be e to the negative t, negative 1 times t times cosine 2t. That is the final answer. Okay, guys? Let us see some more example on finding the inverse Laplace transform of the given function fs. The first example here, that is the fourth example on the inverse Laplace transform, is 3s over s square minus s minus 6. Okay, so it is hard to complete the square here. So what I'm trying to do here is I'm trying to use the partial fraction. Okay, so I got the factors of the bottom, that is s minus 3 times s plus 2. Now what I want to do here is I want to find out the partial fractions. Okay, so let's do 3s over s minus 3 and then s plus 2, right? So this is equals to, you do a over s minus 3, that are the different linear factors, right? You saw these in Calc 2. So b over s plus 2, right? What do? You combine those. So and then you get a times s plus 2 plus b times s minus 3 over s minus 3 and then s plus 2, right? You cancel that from both sides, so you will get basically 3s equals to a times s plus 2 and then plus b times s minus 3, right? So what you do next is set x equals to, say, s equals to 3. If you set s equals to 3, what you get is 9 equals to, this will be 0, right? This will be 5a, right? So 5a. So this implies a equals to 9/5. Similarly, I want to put s equals to negative 2. If I do that, I will get negative 6 equals to, this will be 0, that will be negative 5b. Negative 5b. So this implies b equals to 6/5. You see that? So what you can write this basically is f of s is equals to, so you can write 9/5 and then 9/5 times, you can write 1 over s minus 3, right? S minus 3 plus 6/5 times, you can add 1 over s plus 2. Basically what I'm trying to do here is I'm trying to write a is 9/5, but since this is a fraction, I can write this a times 1 over s minus 3 plus b times 1 over s plus 2, right? So now I want to take the inverse Laplace transform of fs. So this is same as taking 9/5 and then inverse Laplace transform of 1 over s minus 3, right? Plus 6/5 times the inverse Laplace transform of 1 over s plus 2. So do you remember what is the function whose Laplace transform is 1 over s minus 3? But this is just like a, you can see the just the translation kind of s minus 3. It may, there may be e to the 3t or something. But what is the Laplace, whose Laplace transform is, what is the function whose Laplace transform is 1 over s? That is 1, right? The Laplace transform of 1 is 1 over s. So what you can do here is basically 9 over 5. So you see that the Laplace transform of 1 is 1 over s, but what will be the Laplace transform of e to the 3t and then times 1? So I'm multiplying this by e to the 3t. So what I should do is I should replace, so this will be this is, if this is fs, then it should be f s minus 3, right? So replace s by s minus 3, so it will be 1 over s minus 3. This is what you get, right? So the inverse Laplace transform of 1 over s minus 3 is e to the 3t. So I will write e to the 3t, okay? So e to the 3t times, plus 6 over 5. So what is the function whose Laplace transform is 1 over s plus 2? So it is similar to that. So if I multiply this one by e to the negative 2t, e to the negative twice t times 1 will be how much? So the s will be replaced by s plus 2, because if there is minus, there is plus. If there is plus, there will be minus, right? So it will be 1 over s plus 2. This is what we have, right? So it will be e to the negative twice t. So which is the answer? So inverse Laplace transform of fs given by that is 9/5 e to the 3t plus 6/5 times e to the negative twice t. So next example I want to do is fs equals to 2s plus 1 over s squared minus 2s plus 2. Since there is minus 2s, maybe you can think of completing the square there. Okay, that will be easier. Okay, let us try that. So this can be written as, f of s can be written as 2s plus 1 over, you can write s minus 1 square will be s squared minus 2s plus 1 and then plus 1 there. You see that? So because s minus 1 square times, sorry, s minus 1 square is s minus 1 times s minus 1. If you FOIL that, you will get s square minus 2s plus 1. But there is 2, so you can write 1 plus 1 for that, right? You can write 1 plus 1 for that too, and you can use 1 for that, and the extra 1 is still there. Now, whenever there is s minus 1, it would be better if I can write s minus 1 on the top. So let us write that way. I would write 2 and then s minus 1, and I want to balance how much I got. 2s minus 2, but we need plus 1. So it will be, if I write plus 3, that will balance, right? Why I did that? Because I want to match that denominator, s minus 1 square there. So 2 times s minus 1 plus 3 is same as 2s plus 1. So that is s minus 1 square plus 3, right? By the way, this should be 1, okay? This is not 3. This should be 1. So what I want to do next is I want to split the denominator. So I want to do 2 times s minus 1 over s minus 1 squared plus 1 and then 3 over s minus 1 squared plus 1. Now I want to take the inverse Laplace transform. If you take the inverse Laplace transform of fs, you will get ft, right? F of t is equals to, here you can pull that 2 out and then do inverse Laplace transform of s minus 1 over s minus 1 square plus 1, right? And then plus 3 times inverse Laplace transform of 1 over s minus 1 square plus 1. Let us look at this formula. We know that the Laplace transform of cosine bt is s over s squared plus b squared, right? How about Laplace transform e to the at cosine bt? This is basically f of s, right? So this is f of s minus a. You see that? So f of s minus a, meaning all the s should be replaced by s minus a. That's what we get. So can you compare this with the first inverse Laplace transform? So the inverse Laplace transform of this guy will be e to the at cosine bt. But what should be a? A is basically 1, right? And then b is also 1. So you can write this as 2 e to the t cosine of t, right? Plus 3. Look at this one. What is the Laplace transform of sine bt? It is b over s squared plus b squared. So this is basically fs, right? So if you multiply sine bt by e to the at, so this will become f of s minus a, right? So that will become, s should be replaced by s minus a there. So s minus a squared plus b squared. If you compare this with the second, then you will get 3 times. So you will get 1 over s minus 1 square plus 1. So that will be e to the t, right? Because a is 1 and then b is also 1. E to the t times sine t. That is the final answer. That's what you will get for the inverse Laplace transform of this function. Okay, so the last example that I want to do here for this is basically similar to the one. So we will have to do the partial fraction, which is the if you can get the factors of the denominator, the partial fraction is the first thing you should try. Okay, so I tried the partial fraction already. So on the solution, so you can write f of s can be written like this: negative 2 over s square. I tried the partial fraction already, okay? Plus 1 over 2 s minus 2, and then plus 1 over 2 s plus 2. How did I do this partial fraction? I did this thing equals to, I did a over s minus 2 plus b over s plus 2 plus cx plus d, right? Over s square, or cs plus d over s square, and then just get the same denominator, cancel the denominator, and then just compare the top with taking different values of s. Okay, that's the exactly same thing that we did here, but you will have some more. Instead of a plus a over something, b over something, there will be cx plus d for the quadratic term. Okay, you will do cx plus d over s square and then simplify that. Okay, this is what you will get if you do the partial fraction. Now what you want to do is you want to take the inverse Laplace transform, right? Inverse Laplace transform we get. So on the left side you will get f of t, on the right side you will get negative 2, and then inverse Laplace transform of 1 over s square. Let us do that. So inverse Laplace transform of 1 over s square plus 1/2 inverse Laplace transform of 1 over s minus 2, and then plus 1/2 inverse Laplace transform of 1 over s plus 2, right? So what do you get? Negative 2. So what is the function whose Laplace transform is 1 over s squared? That is just t, right? So that will be just t plus 1/2. What is the function whose Laplace transform is 1 over s minus 2? So let's see how does that work, okay? Because we know that, so we know that the Laplace transform of 1 is 1 over s, right? But we need 1 over s minus t. So what should I do? We need to multiply by e to the at, right? So I would do Laplace transform e to the twice t times 1 will be 1 over s should be replaced by s minus 2, right? So it will be s minus 2. That's what you get. So this will be e to the twice t, right? That's what you will get, e to the twice t, plus similar way you will get e to the negative twice t for the third inverse Laplace transform. Okay, so this is how you take the inverse Laplace transform of a function. Okay, so let me talk about the homework problem. So homework problem from section 5.3. There are not many. So it is question number 9, 12, 13, 16, and 21. These are the homework problems from section 5.3. All right, guys.